You've got 3 or 4 different types of questions leading into tomorrow. The first was if it's just like an x to the first power and there's no fractions, right? Those were the very first ones we solved. Then the second ones were where you had a variable in the denominator. So for these, you would multiply by the least common denominator, but you would have to make sure you check for extraneous roots. And then you got into ones like these. So they're both have an x squared, but the difference between these two is the one on the right only has an x squared. It doesn't have an x squared and an x. The other part is that that can't be factored. Like if that was x squared minus 49, I actually could choose to do either of them. I could either use the even root property by adding the 49 and square rooting both sides, putting that plus and minus, or I could factor it using the difference of two squares. So there are going to be some in which you can choose. But because that 43 is not a perfect square, I can't factor it, which means the right side we're going to use the even root property on, number 17. And then 12 has an x squared and an x, and you can't use the even root property on these. So if you have an x squared and an x, you're going to have to factor it. Today we're going to learn a different method that you could use, but up until this point, you would have to factor it. So tomorrow's quiz, you're going to have to like not use what you're learning today, which is kind of going to be a challenge, okay? But so if I look at the left, I'm going to have to factor this. I want to get 0 on the side by itself so I can move the 3 over, but it's easier for the x squared to be positive. So instead of moving the 3, I'm going to move the other 2 terms. So I'm going to add the x squared and I'm going to subtract the 4x. And I'd get 0 equals x squared minus 4x plus 3. And now I'm looking for factors of 3 that sum to negative 4. So it's minus 1 and minus 3. And then you're going to split and solve these. So I get x equals 1 and I get x equals 3. And again, you can just list them. Like this is going to be an open-ended quiz. You can just list them. And the order doesn't necessarily matter. Yeah.
So when there's an x squared and another x that isn't squared, you have to factor.
Correct.
And then when both x or all x's are squared, we square root.
Yeah. Or use the difference of 2 squares if it's a perfect square. So you do get that option. Yeah. All right, so for 17, I'm going to add the 43 to the other side. And I get x squared equals 43. And then I want to square root both sides of the equation. And you can't forget that plus and minus. 43 is prime, so it's going to stay as plus and minus the square root of 43. And you can either write plus and minus, or you could list them out as 2 separate ones. It doesn't matter.
Did we do question number 22?
Okay, so since this one doesn't have an x and an x squared, it just got that thing squared, I'm going to use my even root property. The long way around this would actually be expand and FOIL that out and see if it's factorable, which I would totally avoid if you can. So I'm going to start by square rooting both sides, putting the plus and the minus in front of square root 44, and I get 4x plus 7 equals 44 is 2 and 22, 2 and 11, so this becomes plus and minus 2 square root 11. Then I have to isolate that x. So I'm going to subtract the 7, 4x, and you could say either plus and minus 2 square root 11 minus 7, or you could say negative 7 plus and minus 2 square root 11. That's usually how standardized tests write them out. And then your last step is just to divide by 4. So I'd get x equals plus and minus 2 square root 11 minus 7 all over 4.
Okay, thank you.
You're welcome. And then, again, on a standardized test, you would see it probably written like this, where the negative 7 is on the front. If it's open-ended, which, again, tomorrow's quiz is open-ended, it doesn't matter which way you leave that. Okay.
And can we, under the radical, can there be fractions?
Under the radical, no, because you have to get rid of the square root in the denominator. So, like, that's like number 4, right on the quiz review.
Okay.
You have to rationalize it. It happened on 6 too.
Yeah.
You have to rationalize it. So I posted a video. I went through every single question on a video if you want to go back and watch it if we don't have time to get to it today. Hopefully we'll get time to questions. But
I didn't fill out 19, like all of 19 on this, and I was just confused.
all right, so what we're about to learn, you almost have to like absorb it and then pause your brain for the next 24 hours and then come back to it. So that's the hard part of moving on, but we didn't want to give you a quiz today. That would have been fun. So this is not on your quiz. It will be on your test, which is a week from today. but it's not on your quiz for tomorrow. And this is solving using the quadratic formula. So any question that has an x squared can be solved using quadratic formula. Only those that are factorable can be factored, right? And only those that don't have an x squared and an x can be solved using the even root property. So there are limitations on those. But for the quadratic formula, anything that's got an x squared, okay, can be solved, or the highest exponent would be the x squared, can be solved using the quadratic formula. So the first thing you have to do is learn the quadratic formula. So when you are given an equation and there's an x squared, and it can be an x squared and an x, but it doesn't have to be. As long as there's an x squared, you can use quadratic. You want to put it in order of highest exponent down to none. The term in front of the x squared is your a, the term in front of your x is your b, and then the constant would be your c. And this, again, is your quadratic formula. Negative b plus and minus the square root of b squared minus 4ac all over 2a. There's a super annoying, slightly catchy song on YouTube in which they will sing this to Pop Goes the Weasel. Singing is not my strong suit, so I'm going to save that for you guys. If you'd like to Google it later, you go right ahead, okay? You literally go to YouTube and you say, Pop Goes the Weasel quadratic formula, and I promise you it's there, okay? The good thing is it will get so stuck in your head you'll never forget it. But maybe do that after tomorrow's quiz because you don't want to be singing Pop Goes the Weasel during tomorrow's quiz when you can't use it, okay? So this is going to produce two answers because it's got the plus and minus. So that means that there will always be two answers unless what's underneath is 0. Then there's only one. But there will be then that's how you will get your two answers. Kylie, do you have a question? Yeah.
Yeah. Is the web assignment due tomorrow?
No, it will be due Monday. Yep. All right. So looks like this. And we are going to use the quadratic formula to solve these, but at some point this would just say solve and you'd have to figure out that, like looking at number 1, it is not factorable. There's no factors of 2 that sum to -4, so you'd have to use the quadratic formula, okay? So I'm going to make sure it's in order. It's set equal to 0. It's in order from highest degree down to none, and it already is. And then I'm going to identify my A, my B, my C. A is what's in front of the x squared, which is what? 1. B is what's in front of the x. -4, you keep that sign. C is what's by itself? +2. And then it is negative B, which is -4, plus and minus the square root of B, which is -4 squared, minus 4 times A, which is 1, times C, which is 2, all over 2 times A, which is 1. Now I simplify. So -4 just becomes 4 plus and minus the square root of -4 squared is 16 minus 4 times 1 times 2 is 8 all over 2 times 1 or 2. So then I get 4 plus and minus the square root of 8 over 2. And then I see if I can break 8 down. This is 2 and 4, 2 and 2. So I can bring out a 2. And I get 4 plus and minus 2 root 2 over 2. Can you simplify that? Yeah, because all 3 terms are divisible by 2, I can divide 2 into itself and into 4 twice. So I get 2 plus and minus the square root of 2. And you can leave your answer like that. If you were to separate it out, it would be 2 minus root 2 and 2 plus root 2. So both would be right. Questions on that one? Alaska.
Why did you switch? Oh, wait. Okay, wait.
Good?
Yeah.
All right, go to 2. It's set equal to 0. It's in order of decreasing degree. So my A is what? 1. My B is -3 and C is -2. So So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 3 becomes positive 3 plus and minus the square root of negative 3 squared is 9. Negative 4 times 1 is negative 4 times negative 2 is positive 8 over 2. And I get 3 plus and minus the square root of 17 over 2. Can you simplify square root 17? No. So on an open-ended question, I would keep it just like that. Standardized tests love to separate that. So like, think in 2 weeks you're taking the PSAT, right? So they will like to separate it out like this so that they each get a denominator. And then if either of those could be simplified, they would. So just keep that in mind. Those would be the same thing. Multiple choice will probably have it written like the second, but open-ended, I'd take either one. Questions on that one? Yep,
Is the song about the formula?
it is. Yeah, she sings the formula. It's lovely. All right, 3. There are fractions. So this is the part where you freak out, even though you're not supposed to, because what can you do with those fractions? Get rid of them by multiplying by the least common denominator. So what is the least common denominator this time? 12. Each of these are going to get a 12. So 3 goes into 12 4 times. I get 4 times 2 times x squared, so 8x squared. Minus comes from here. 4 goes into 12 3 times. 1 times 3 times x would be 3x. Equals 36. Then what? Good. Got to get it equal to 0. So I'm going to subtract the 36. 8x squared minus 3x minus 36 equals 0. My A is 8. My B is negative 3. C is negative 36. I get negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. So I get 3 plus and minus the square root of 9. Negative 4 times 8 is 32. Will be negative 32. Times negative 36. Which is 1152. Over 16. So I get 3 plus and minus the square root of 1161 over 16. That's not an even number, so I can't have 2 go into it, but if I add the digits, 1 plus 1 is 2, plus 6 is 8, plus 1 is 9, this means it is divisible by 3. So 3 goes into this. $387 times. Then I would add up the digits again. 3 plus 8 is 11, plus 7 is 18. That means 3 goes into that one too. 387 divided by 3, it's 1, 2, 9. 129, again, not even. Add up my digits. 1 plus 2 is 3 plus 9 is 12. That is also divisible by 3. It'd be 43. And then 43 is prime. So these two 3's bring a 3 to the outside. And then 3 times 43 is 129. The same thing does not go into 3 and 16. So this is my answer. Daniela.
Are we gonna have ones that big on the test?
There's a possibility, yeah. To be honest, we haven't finalized your test, but you can see stuff that you're going to have to multiply and then break down. Not on the quiz. Remember, this is not on the quiz, but on the test.
And
Yeah.
you said that it was divisible by 3 because it's a multiple of 3.
If you add the digits and what you get is a multiple of 3, then the whole thing is. Yeah. So you're looking for, I would look for zeros, 5s, those kinds of things, and then is it even? And then add up the digits. Rodrigo.
What happens to the square root of 9?
So that got blended together. It's not square root 9, it's square root 9 plus 152. So be careful and don't separate that out. You got to add them together before you can square root. Questions? All right, do 4. All right, so we said the first thing we have to do is rearrange this so that it's in decreasing degree order. So x squared plus 8x plus 10 would equal 0. And then my a is 1, my b is 8, c is 10. So it's negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. I get negative 8 plus and minus the square root of 64 minus 40 over 2, which is negative 8 plus and minus the square root of 24 over 8. No, sorry, over 2. 64 breaks down into like 4 and 6, and you could bring a 2 out. So this is negative 8 plus and minus 2 root 6 over 2. And then because all 3 of those coefficients are divisible by 2, once, and 4 times, my answer is negative 4 plus and minus the square root of 6. Raise your hand if you got it right. Okay, good. Questions? Yeah.
So if you were to change the order like right away, you take the whole question off.
If you weren't, like if you made B 10, yep, it's the wrong thing. So look at 5, right? So 1, it's a little bit like what we did the other day where you've got parentheses squared and we normally would square root both sides of that equation. But what's on the other side of the equation is an x term, which means you cannot do that. So for these, you actually have to expand and FOIL that x plus 6 and then get everything to one side and then use your quadratic, okay? So you can't, 1, we're not going to distribute the exponent because we stopped doing that weeks ago so that I don't lose my mind, right? We're going to expand and FOIL this or use, God bless you, the perfect square shortcut, which is square the first, square the last, and then double the product of the terms. So 6x times 2 would be 12x. So you either FOIL out the x plus 6 and x plus 6, or you use that shortcut. It still equals negative 2x. Rodrigo.
How do we know when we can't factor and then when we're going to use like the quadratic?
So you wouldn't know you couldn't factor until you literally tried. So like I would have started both those kinds of questions the same way right now. I wouldn't have made that decision yet. I would then add the 2x. And I would get x squared plus 14x plus 36. And then if this is test, I'm going to say, can I factor that? Are there factors of 36 that add up to 14? If I can, then I'm going to factor. If I can't, then I'm going to use the quadratic. Unless it told me I had to use one way or the other. Yeah. Noah. It's square the first term, square the last term. Those are first and last. And then double the product of the terms. So now A is 1, B is 14, C is 36. Negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. Negative 14 plus and minus the square root of 14 squared is 196. 36 times 4 is 144. Negative 14 plus and minus the square root of 196 minus 144 is 52 over 2. 52 is 2 and 26, which is 2 and 13. So that becomes negative 14 plus and minus. The 2 goes to the outside. And then each of these are divisible by 2. So I get negative 7 plus and minus the square root of 13. No. Say again?
How did you get 14?
When you, so I FOILed out x plus 6 squared and got that. And then I had to add the 2x from the other side. When you're doing the shortcut, the 14 wasn't there. The shortcut produced the 12. Double the product. So the product of x and 6 would be 6x times 2 is 12x. That's how that middle term got there. And then we added the 2x. Questions so far? Yeah.
If there was the greatest common factor in the beginning, what do you...
There are 2 scenarios that can happen with these that haven't happened yet. The first is if what's underneath your square root. So let's say I go 2 plus and minus the square root of 25 over 2. Let's say it looks like this, right? In this case, I can actually square root that 25. So this would become 2 plus and minus 5 over 2. And then I have to keep going. This gives me 2 answers. One in which it's 2 minus 5 over 2, and one in which it's 2 plus 5 over 2. So negative 3 halves and 7 halves. So if you can keep going, because you can square root it, you have to. This is an example of something that would have also been factorable. So that's by the time we get to the test, there are multiple ways to do these. The other thing is if you get something that underneath has a negative number, can you square root a negative number? No, so this would result in a no solution. It's actually no real solution, and we'll learn more about it when we get to 1.5. But we could not do anything with that because it has a negative. Lauren?